Questions?
Yeah, first of all, just thank you for that very lucid presentation. I think there are a lot of good points to take away on the last slide in particular. I just wondered, this comes back to something that Zubin said earlier, and your use of the term sort of lowering the barrier to entry. Zubin said, for example, it's possible now to get into some of these research topics without even knowing what a derivative is. As these tools mature and harden and things come down to the level of being commoditized engineering tools, fieldable, deployable systems, how do you see the sort of research strand going in one direction and then the sort of engineering productizing strand going in another direction? In other words, is it a good thing that you can innovate in this area without even knowing what a derivative is? I think in some sense it probably is, but could you pick that apart for us a little bit?
Yeah. I think that it's actually great. So you can program a computer without knowing what a register is. And in fact, most people who program don't really have a clear grasp of compilers and architectures and all of these things. They just understand, if we come up with the right abstractions for these things, it becomes easy, right? Most people who build apps, they don't really need to understand the details of TCP/IP, and that's better, right? And I think the same thing is kind of happening with machine learning over time. I think that if you want to be innovative at how the tech works, then that's where you want to dive into the guts. But there was an example of somebody who built a cucumber sorter for his parents' cucumber farm in Japan by hacking together a Raspberry Pi and a TensorFlow model, and had his mom sort enough cucumbers that was training data. More power to him, like if he knows what a Jacobian is, but he definitely does not need to know what a Jacobian is. No.
You said, amongst other things, that data is now a commodity and everyone has access to it. Is that really the case? We might think that at Google you have access to lots of data and data sources that other people don't have access to, similarly, but for different data sources at, say, Amazon and so on.
Yeah, so I think the thing about data is that because what is working in practice is learning by example in domain, right? So if I want to build a spam classifier, I need to have a historical log of emails. But having those emails doesn't actually help me, honestly, even with things that seem related, like speech recognition and so on and so forth. So within whatever your objective or business is, right, you have to invest in getting the data within your domain, right? So, if Uber wants to do geographic predictions around ride demand, right, obviously they're going to have had those data, and someone who doesn't yet have a car company is going to have some difficulty, doing that particular operation. But I think that it's more localized, I think, than a lot of people imagined. It's not as though a sort of a general maw of data is actually useful to building better machine learning systems.
Neural networks are actually bad at summarizing a sentence and creating what you labeled as thought vectors on there. We've seen empirical evidence of this. The attention model is implicitly a conceit that you can't encode a sentence as a vector and need to bypass that. The Stuskiver paper you cited was actually re-ranking a phrase-based machine translation system.
Yeah.
And I'm wondering about the dangers of fluency and adequacy. In machine translation, we can easily create very fluent sentences from some vector that have nothing to do with the input. So our system that was translating a sentence with the reference about faster and more precise riveting actually produce the output no, 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 because it happens that that's very fluent in the training corpus. And I think that this graph, for instance, is also perhaps overselling fluency over adequacy, and that's dangerous because people will think that it's a correct translation if it sounds good.
Right, so these are great questions. So I'll try to take them in turn. So the first paper here, the one that was in 2014, was using this kind of system to just re-rank existing systems, because that was all we could do at that time. The last paper, the one of September this year, is complete end-to-end synthesis. And that's actually what we serve now live for 8 languages, complete end-to-end translation. The question of dimensionality and summarization, right, with the thought vector is a great one. There's I was briefly a physicist, and there's an old physicist cop-out to this, which is that, well, I can always do it with more dimensions, right? So I can actually take the attention vector and treat that as a way of inspecting it, but I think that actually is a cop-out. What's really important here is that this goes back to the earlier question about getting away from simple feed-forward function approximators and doing something more intelligent. So I think that the first step to this is having systems that move through data and decide when to terminate. So this system doesn't decide that it's done translating until it emits the end of sentence token, right? So it has to decide to halt, right? That's the first kind of programming primitive that it had. The ability to selectively look at the input, right, by using the attention vector, I think is now something that, again, is another step away from being just another function approximator. And when people doing great research on trying to use memory, I think that we're moving into a space where what we're doing is we're actually building systems that are, what we're building with these Lego logs are programs that are differentiable, and the set of primitives that they have right now is very, very limited, but the set of primitives that they have seems to be growing, and they're actually able to use productively. So it's true, we tried this without attention, and it doesn't work nearly as well. In the case of doing email reply, attention actually didn't particularly help. So in that case, you could summarize the gist of an entire email with a single vector, but the details of the translation were not good. But your last question is one of the things that I think is really important, which is this trade-off between fluency and sufficiency in translation. And it is true that the new system that learns from data is much more highly fluent, but occasionally just goes totally off the rails, right? And it will make a valid sentence, a sentence that sounds like something, even though it has greatly diverged from what the input sentence is. But I would say that at the present time, this is actually an engineering challenge. This is a tractable level of quality. And I agree that if you have a system that diverges from the intent of the sentence, but still captures fluency, that can be frustrating or even dangerous for users because you might think that it has done a fine job without erroring. But I think that these are tractable things, and I think this actually comes back to Zubin's earlier point about having a notion of confidence. And these systems for these kinds of applications don't have an internally consistent notion of confidence. And I think that is the right long-term solution to this, is to both have our maximum likelihood estimate and also to capture confidence.
Okay.
Sorry, that was a long answer.
So just two comments. One is your great example on the air flight. The flight is slightly wrong. It's as if in 1800s there was not enough air, also in addition to not having engines, because I think the data part is extremely important. Some of us are old enough to remember that vision used to be essentially Lena, the picture, and now we have ImageNets and so on. So I think that should not be undersold at all. I think it's connected to computing, but not just fast computers. The second point I have, probably comes back in the afternoon, is this idea that in jest I would say that would you consider putting Gmail readers for Gmail writers so that we can actually, as a human race, save 10% of our time for the automatically generated emails. And I think those of you old enough might remember Real Genius. But anyway, the bigger issue is, should you actually put some kind of a flag when these things are generated by machines? Just like on the internet, there are these things saying how to get a human operator. Right? For any 800 number. So I would like to, for example, for my Gmail, to see whether in fact somebody wrote it or it was like one of these multiple choice questions that they selected. And especially given the point about fluency versus adequacy.
So this is a great. So first, on your point about data, I completely agree that we did have to get sufficiently sized data sets. We did not have those in the 80s. We had them in the late 90s, though. And for many problems, for speech recognition and image recognition, things that used to be really hard, you can fit all the data that you need on a hard drive that fits in your pocket, right? And so I do think that the data is becoming more available, but I agree, it really is important. To your question about, how do we need flagging that this was automatically generated? So I think this actually comes down to the interaction between humans and the people who care about using the product and the people who design the product. And this is one of the things reasons why I think it's very important to educate not just engineers about what machine learning is, what it does, and what its weaknesses are, but to educate designers and product inventors and business leaders about what the strengths and limitations are. Because it would actually be a terrible product for this thing to reply to emails without you. Right? No one wants that product. I don't want that product, right? But what I want is something that on my mobile phone gives me options that I can either ignore or use and actually usually edit. So in that 10%, that includes not just cases where people selected a single one, but where they selected it and then they customized it in some way, right? They edited it a little bit. So as long as there's a human in the loop to approve what the message is, right? I think that it's kind of in the age-old tradition of yes, write a nice recommendation letter and I'll sign it, right? It's that kind of approach where there's another agent in the loop, but we should use that very carefully.
Well, thank you for a very interesting talk. I was actually very intrigued by you including a slide about distribution and fairness in all of this. Are you basically suggesting that the AI and machine learning is now a new kind of wealth? And it's, as we consider its impact and application in many sectors of economy, what are you basically seeing is going to happen in our understanding of economics?
Yeah, so
by
I would
having
say,
these tools available.
I would say whether or not I consider it a form of wealth depends on whether or not I consider technology in general to be wealth, right? So this is basically, it's a new set of tools, and it's the knowledge of how to use those tools. And it's definitely the case that a group of people who have the tools and understand how to use them can be more productive than people who are somehow deprived of these tools. And I think that that's actually part of the reason why so much of the community has rallied around open sourcing and releasing the tools, so the tools are just out there. All of the major players now have open sourced what their tools are, and the desire to educate people to use these tools, whether on college campuses or in online courses or through self-taught things, there's finally a textbook on this kind of stuff. I think it is really important. I think that if someone were developing these kinds of tools and the techniques and not sharing them, it would be actually very problematic. And I'm glad that we're in a state where these things are being widely dispersed.
But notions of fairness doesn't happen a lot in technical conversations or when we talk about tools and how to distribute it. I agree with that notion.
Yeah.
I'm not pushing back, but it was intriguing to see, to talk about AI and fairness in the same presentation.
Yeah, I think a lot of people in this community really care about getting it right.
I wanted to respond specifically from the fairness. That's okay to jump in. I apologize for Jim for some situation I couldn't use. So in fact, conversation about AI fairness are happening. And I also wanted to, so your point about democratization of the access to tools is a very good one. I think it's a very important thing that is happening and needs to happen more. And TensorFlow has done a great job in that respect. But I think democratization of tools only works when the ability to use the tools is also democratized. So for example, if a company is building tools to decide who gets credit, I as the consumer who wants to apply for a loan can't use any tools to decide whether someone should be allowed to give me credit or not. I am helpless in some sense to be controlled by the decisions that company makes. In other words, whether I should get credit or not. So there's a certain asymmetry of power here that comes from using these tools that even making tools open source and giving people access will not solve. And to that point, I think there's I think we'll maybe talk about some of this tomorrow also, but there's a much larger discussion around how to ensure fairness and transparency in the use of these tools. That goes to the issues of interpretability, the problems of the obscurity of things like, for example, deep learning and attempts to make them more transparent. So there's a much larger conversation that is happening, so it's not, yeah.
Yeah, and I should say that this is meant to be a teaser, right? So that we're all excited for our coming sessions.
So, So being from UC Berkeley, so very nice talk. So the first question is kind of related to the fairness, but in a different way. So my understanding that actually a lot of the books in machine learning or AI actually have a lot of labeling in there, and that's kind of implicit, I'll call human intelligence crowdsourcing. And I think very, very crucial. You can have the biggest computing power, that's very basic data. And I haven't heard a lot about the economics. People usually get paid very little to do these mechanic Turks jobs. And I feel like especially with traditional job disappearing, and this type of job probably more and more available. And it would be interesting to hear how these people here consider that should be more upfront, because I think it's really a human and machine collaboration. AlphaGo, a lot of chess books went into there. So the other question is, I know the genomic people, I work on genomics, have been trying deep learning. So it's a very different application area, and I just want to hear your off the cuff, like thinking about how successful that will be, or what other things to be careful about. Because here we have a lot of implicit validation, right? We have a lot of neuroscience and cognitive science support this. There we don't see things, it's molecules and all that.
Yeah. So to your first point about data, it's absolutely true. It's very important, and I think that it's what we want to do is it definitely is a human machine collaboration, right? We are the ones who teach the machines what to do by the examples that we give them. This has some interesting implications. One thing that I've been trying to push a lot that I think a lot of people miss is that if there are unconscious biases that are present in the people who label the data, the machine will learn to blindly recapitulate those biases in its determinations, right? And I think that that's an important part for us to think about in terms of fairness, which is that we have to be wary of the fact the people who build these systems need to understand that the machine learning system isn't magically unbiased. It is just doing what it was shown to do, right? So if the data have poor behavior, it will recapitulate them. But to your point about compensating people for doing labeling, I think that it makes a lot of sense. For us to do the diabetic retinopathy paper, we had to pay board-certified ophthalmologists to label images, and they did get higher than the standard mechanical Turk rate. To your question about genetics and genomics, I think that there are opportunities there. So we recently had someone from our team publish a paper called Deep Variant that's about using convolutional deep neural networks, I think it's convolutional, deep neural networks in order to look at gene sequences to do a particular kind of variant analysis. That's one kind of opportunity. Vint mentioned one on saving power in data centers. I think that in all of these domains, it's not going to be for people like me who helped build the applications for systems that I understand, going and moving on to all these other applications. What we want to do is we want to get geneticists educated about what the tools do and don't do, and get them the tools, and then it is their good taste to identify which subparts of their field will yield to these approaches, where it is appropriate, where it makes sense. Because otherwise, if you take a random graduate student in computer science or computer vision and you tell them to attack genetics problems, they will solve random garbage, right? So,
thank you.
Hi, Greg. I support a team called Applied Machine Learning at Facebook. So I was listening with a lot of attention, and I want to say fantastic work. I want to ask a very, very different set of, not a long set, don't worry, 2 questions only. One is, what have you learned in helping product teams across Google migrate to TensorFlow? Has that been like a smooth process, or have you guys had to concoct some alchemy to get that done?
A software migration that is a smooth process. I'm not sure that has ever happened in the history of software.
And then the other one is more about incentive structures when you have collaboration between research and engineering and production. That's something where it's intersection where my team lives. Super curious to know also about lessons learned on enabling both sort of long-term risky projects with uncertain outcomes, with being willing to be on call with the product team, because like you said, in some of your applications, if it breaks, you need the scientists who build it to sort of be there.
Yeah. So to address your first question seriously about trying to get people to use TensorFlow, I think it's really important to understand that systems like TensorFlow are second generation machine learning libraries. The first generation libraries were designed by researchers and engineers, and they were terrible to use. They even contain some of my code, which we really don't want. And I think it's important to understand that we're refining how we're doing these things, and we're getting better and better at coming up with what the right abstraction is. And I think that we've finally gotten to an abstraction that's teachable, and indeed one that is amenable to even higher level abstractions being able to be built on top of it. To be clear, TensorFlow is kind of a middle level of abstraction. It's very easy to extend it by putting something simpler on top of it. And I think that that's been really important to being able to deploy it really widely and get people to, you have a couple people hack up, a higher level thing that sits on top of it. In terms of interacting with products and research teams and incentives there, I really do think that it's critical to have this kind of incentive structure where if you really make something better, everybody gets credit, right? Everybody wins, right? It's not like a not invented here problem where, someone, if it's from another team, it feels like it's different. All of these things come out of tight collaborations between, Gmail and the brain research team, or the translate team and the brain team, or, various teams working together, sharing credit, and just being excited about making something that's better. I think that that's kind of the most important thing, and I think the other thing is that it's really important to understand that there's really needs to be a sense of ownership, and I think that that comes to your notion of support, right? You're not really going, the people who get really excited about Jacobians, probably shouldn't be trying to, wear a pager in order to get Gmail up and running. They're just not going to do a good job. So you really want to build these things as collaborations, and think of machine learning as just another part of this complicated software system, right? Just like networking and databases and all of these other things that we maintain and work together. And yes, when there's a deeper problem, we do a postmortem and a drill down and bring in the experts, but most fires have to be put out by the people who really own the product in particular.
Okay, well, let's thank Greg and all the speakers this morning. And let's have some lunch, and there'll be a panel discussion after lunch.
Yeah, a couple notes about